In this video, we're going to discuss ionic compounds, or ionic bonding. Before we do, a reminder, compounds are any time you have two or more elements that are chemically combined to make a new substance. Good examples of that are water and salt, or hydrogen peroxide. What we're going to take a look at is one of the ways that those compounds form, and that is an ionic compound. But first, you need to know what an ion actually is. An ion is an atom or a group of atoms that becomes charged, and that's because they lose or gain electrons. Electrons have a negative charge, so an atom that gains an electron becomes slightly negative, and an atom that loses an electron becomes slightly positive. We're going to take a look at how that actually works. So we're going to use sodium. Sodium is an easy element for us to use because we're familiar with it. It's number 11. So number 11 means that it has 11 protons in the nucleus. That also means that as a neutral atom, it has 11 electrons. And those electrons are in specific energy levels of the electron cloud. In sodium, there's one electron out here by itself in the third energy level. That's the valence electron. There are 8 in the second energy level and 2 in the first energy level for a total of 11. So there are 11 protons, 11 electrons. But sometimes a sodium atom will lose its electron, and if that happens, it becomes a little bit positive because then it has 11 positive charges and 10 negative charges. We're going to also take a look at chlorine. Chlorine is number 17. Chlorine has 17 protons in the nucleus, and it has 17 electrons in the electron cloud. That means that it has 3 energy levels, but in its third energy level, it has 7 valence electrons, and it also has one space where there could be an electron, but there isn't. So this is how ions form, and it's how ionic bonding occurs. If sodium gets close to chlorine and there's enough energy, this electron will jump from sodium to chlorine and fill in this blank space. That means that sodium loses that outer energy level because there's nothing in it, and chlorine has now a complete outer energy level. But these are no longer considered atoms, they are now ions, and that's because sodium has 11 positive charges, just like it did at the beginning, but it has 10 negative charges. That means that it's slightly positive. It has a positive charge. That's what makes it an ion. Over here, we now have 17 protons, just like we did in the beginning, but we now have 18 electrons, or 18 negative charges. That means that now this is negatively charged, making it not an atom, but an ion. If you have a positive and a negative charge close to each other, they attract and they will stick together. That's what causes the bonding to happen. So this is an ionic compound. When these two stick together, you get not sodium and chlorine, you get sodium chloride. That's an ionic compound. It's important to understand that most of our ionic compounds occur between things in these two columns and things in these two columns, and I'm going to explain how that works. Everything in this column, lithium, sodium, potassium, rubidium, cesium, everything in this column has one valence electron, just like sodium. Everything in this column, fluorine, chlorine, bromine, iodine, all of these are missing one electron in their outer energy level. So the things in this column stick nicely to the things in this column through ionic bonding. The same thing is true in group 2. In group 2, we have beryllium, magnesium, calcium. They have 2 valence electrons. Over here in group 16, we have oxygen, sulfur, selenium. Those are missing 2 electrons in their outermost energy level. So these two electrons will jump to these atoms and cause the same kind of bonding that occurred with salt or sodium chloride. Hopefully that makes sense when it comes to ionic bonding and how that works. Now it's also important to understand how we name these things. We don't call it sodium chlorine. That's not what we say. We say sodium chloride, and that's because we use the positive ion's name first, and then we change the negative ion's ending to IDE. So when we have sodium and chlorine in an ionic compound, that becomes sodium chloride. If you have magnesium and oxygen, that becomes magnesium oxide. If you have something like potassium and fluorine, that becomes potassium fluoride. So when you hear names like that, hopefully you'll go, oh yeah, that's an ionic compound. That means that they're things from this side of the periodic table bonding with things from this side or these two columns of the periodic table. It's also important to understand that once you have an ionic compound, it becomes neutral as a whole because you still have equal numbers of positives and negatives. So when we had our sodium atom with its 11 positive charges and it lost an electron, it became slightly positive. When we had our chlorine atom with 17 positive charges or protons and it gained an electron, it became slightly negative. But if you add this together as an entire compound, you still end up with 28 positive charges and 28 negative charges, meaning that the entire compound then becomes neutral again. And the last thing that we're going to mention is that there are some properties or some characteristics that are always going to be true of ionic compounds. One of them is that they tend to have a crystal shape. So if you take a look at a small grain of salt, it looks like a tiny crystal. That's because it's an ionic compound. Another one is that it has a high melting point. You can't melt salt at a low temperature. It has to be a high melting point or a higher temperature than most things. And the last thing is that they can conduct electricity. So hopefully that gives you some information about ionic bonding and ionic compounds. Next, we'll cover covalent bonding.